are not violent, and those who are predicted as being high risk are actually violent. So if everybody was in that diagonal, you would have 100% prediction, 100% accuracy in your prediction, and you would have no false negatives and false positives. And one way in which you can improve the sensitivity of your prediction to 100% is to predict that everybody will be violent. If you predict everybody's violent, then actually you can't have any false negatives. Okay. You'll have an awful lot of false positives, of course, but anyway, that's something to be considered. And false negatives are something to be avoided if at all possible. You won't recognize this man, but he's Microfiche, who was a weather announcer in the UK, and about 30 years ago, he, on a Sunday evening, was giving the weather forecast, and he said that there's going to be a storm in the English Channel, but actually it's going to miss the south of England. He was quite categorical about that. And in fact, he was wrong. And it hit the south of England, and it caused an enormous amount of damage. And that led to what I term the Microfiche effect. That is, never ever make the mistake of identifying a false negative. Don't ever predict that something bad won't happen, because if it does, then you're in a very serious problem. It doesn't actually matter too much if you predict that something bad does happen, and it doesn't happen, because people then feel relieved. And there's evidence from prediction of hurricanes in the United States that you predict a hurricane, people leave their abode, go inland to avoid the effects of it, and the hurricane doesn't strike, and they're not too worried, they come back. But if you predict that a hurricane won't occur, and it does occur, then that's a very serious matter for you as a clinician. So there is a tendency among us, I think, simply to over-predict violence for that reason. You'll be criticised, and other people will have got it right. Now that's one point. The second issue is the actual value, or the predictive value of the test. And that depends on a critical matter called the base rate. And I'll just illustrate that for you as follows. Let's suppose that you have a population of 100 people, and 20% of them are going to be violent. That's the base rate of violence. And you have a test which is 0.7% accurate as regards sensitivity and specificity. So that's a pretty good test. You're right 7 times out of 10. Of those 20 people that your test is predicting will be violent, actually 14 of them are true positives, and 6 of them are false negatives, and 56 of them are true negatives, and 24 are false positives. The positive predictive value is this figure, 14 over the number of true positives plus false positives, which is 0.37. That means approximately that you will be wrong 6 times out of 10 with that kind of test. Okay, pretty good test, and you're applying it correctly. With a base rate of 20%. Now let's suppose that we change the base rate to 6% and do the same calculation. You've got 4 true positives, 2 false negatives, and so on. Now the positive predictive value is 4 over 4 plus 28, which is 0.1. So now, by just changing the base rate of violence, your prediction goes from from being right 4 times out of 10 to being right 1 times out of 10. Simply because of the base rate phenomenon. Nothing to do with your test and that you're not applying it correctly. It's simply a function of the base rate. So, for a base rate of violence of 20%, a good instrument will be wrong about 6 times out of 10. For a base rate of violence of 6%, the same instrument will be wrong about 9 times out of 10. And for a base rate of violence of about 1%, which is probably what about we are trying to predict, the same instrument will be wrong about 95 times out of 100. So your chances of being right are very, very small indeed. But the problem is, and the best way of being correct is actually to predict people not being violent. But if you predict people not being violent and they are violent, then you get on the neck in a very serious manner. So whatever you do, you're stumped, basically. So that's one problem. The second problem, and this actually is a much more general issue, and it applies to medication, prescribing medication as well. Can you extrapolate from general findings about a group to a specific individual? And if you do, what is the margin of error associated with it? That's the question. Okay? Because all of the trials that have been mentioned by Dr. Mohan and others actually come from group data. They're not about, they're made up of individuals, but they don't apply to the individual. So the question is, how accurate can you be in applying those data to a single case? And you always have a single case in front of you. You don't have a group of people that you're treating. You're treating John Smith or whoever it is. Okay? So that's what the issue is. And this was a paper in the Lancet by Rothwell. Actually, he was talking about surgery to the neck. But he said basically that a single patient can't experience death 50% of the time. You know, you're either dead or you're not dead, but you're not dead 50% of the time. That applies to the group. Now I'm going to go through this I'll skip some of this, but I just want to take you through a particular exercise which David Cook and Christine Mitchie, they're researchers from Scotland. Now there's an instrument called the PCLR. You may not be familiar with it. It's the hair psychopathy checklist, and it's a measure of being a psychopath. And the more psychopathic you are, the more violent you're likely to be. I think everybody would accept that. And this, in fact, is a very good predictor of violence among psychopaths. So what Cook and Mitchie did was they gave the PCLR, this measure of prediction, to about 250 prisoners who were about to be released from a Scottish prison. Okay? And they followed them up for about 2 years to identify those that would be violent or not. Okay? Very simple, straightforward design. And this is what they found. And it's not surprising, since this is a good instrument and it was applied appropriately, that this is the score of their psychopathy score. It goes from 0 to 40. 40 is a perfect psychopath. Okay? And obviously the more psychopathic you are, and the more likely you are to violently recidivate. And this is the line, correlation line between those two measures. Okay? The higher the psychopathy score, the more recidivism. All right? These two lines here are the confidence intervals around that prediction. Okay? And you can see that as the psychopathy score increases, in other words, you get into more violent people, actually the width of the confidence interval increases. So your margin of error actually increases with higher levels of psychopathy. So the very people that you really want to predict, you're actually more likely to be wrong. Okay? So that's for the group. What about for the individual? These are the confidence intervals for the prediction of one individual in this series of patients, and it goes from 0 to about 99.95%. There's a huge margin of error. It couldn't be greater. So you can't actually apply group data, this measure, to an individual and be very confident in its accuracy. That's the message. And this was done a second time with a different data set. This comes from the MacArthur study in the States. And you can see very sort of similar findings. The margin, the confidence interval is much tighter actually with this data set, largely because it's a much bigger data set and they followed people up for only 20 weeks. But the confidence interval for the individual, which is what we're interested in, is almost identical. So the message is that when you apply group data to an individual case, you have a very wide margin of error. Very interesting paper, well worth reading. And that was their conclusion. On the basis of empirical findings, statistical theory and logic, we conclude that the predictions for further offending cannot be achieved in an individual case with any degree of confidence. And that's exactly what you're being asked to do as a psychiatrist. Okay, I'll skip that. And this is a quotation from John Adams, who's a geographer, basically saying that the insurance industry